Okay, so this brings us to our second example of using the trigonometric functions at any angle definition. So we're going to use that to find the values of the trigonometric functions at the, or some of the trigonometric functions at the quadrantal angles, right? Those are the multiples of 90 degrees. So to start off with, they want me to evaluate, if possible, the cosine function and the cosecant function at the quadrantal angle 0 degrees, aka 0 radians. Okay? So the way that works is you sketch that angle in standard position, and for 0 degrees, that's very, very easy. And then you identify a point that lies along the terminal side of that angle. Okay? So if you picture a 0 degree angle in standard position, that would just be the positive x-axis. So pick any point on the positive x-axis. They went with 1, 0. And so that point has, of course, an x-coordinate of 1 and a y-coordinate of 0. So now, there it is. I was hoping I had a picture in here. And of course, the point 1, 0 is 1 unit away from the point 0, 0. Okay. If you really felt like you needed to, you could use the formula r equals the square root of x squared plus y squared to figure that out, but you probably don't need that, right? It's obvious that's 1 unit away. So I have x is 1, I have y is 0, I have r is 1, and those three things are all I need to evaluate any of my trigonometric functions. For example, the cosine of theta is defined to be x over r. X is 1, r is 1. That means the cosine of 0 is 1. And the cosecant of theta, that's defined to be r over y. R is 1, y is 0. And of course, 1 over 0 is undefined, which means the cosecant of 0 is undefined. Okay, the second example is very, very similar. Evaluate, if possible, the cosine and the cosecant functions at the quadrantal angle 90 degrees, aka pi over 2. So if you're watching the video, I'll ask you to pause the video and see if you can do this one similar to how I did the last one. And we'll compare notes when you're ready. All right. So for 90 degrees, the picture looks like this. So the terminal side of a 90-degree angle is along the positive y-axis. So the easiest point to use is 0, 1. So hopefully that's the point you picked. You can pick any point along the positive y-axis, but that's the easiest one. Okay, because that's the point that makes r equal 1. Okay. So now we have x is 0, y is 1, r is 1. So again, we're doing cosine and cosecant. The cosine is still x over r. So the cosecant of 90 degrees is 0. And I'm sorry, the cosine of 90 degrees is 0. The cosecant of 90 degrees would be 1 over 1, which is 1. Okay. All right, so let's try just one more of these. I actually have 2 more in the PowerPoint, but I don't think we need to do all 4. Let's see, should we do, yeah, I think this one's just as good as the other one. Okay, so one more time, now that you've seen 2 of those, hopefully you can hit this one right out of the park. So if you're watching the video, I'll ask you to pause the video and try this one, and we'll compare notes as soon as you're ready. All right, 180 degrees, also known as pi radians. So if you draw that angle in standard position, it looks like this. So pick any point along the negative x-axis. Simplest one would be -1, 0. Notice that the distance from the origin to -1, 0 is 1. R is always going to be, well, it's never going to be negative, put it that way. All right, so and again, the cosine and the cosecant, I kind of wish they had picked some different functions once in a while, but that's okay. The cosine is x over r, which is -1 over 1. So the cosine of I'll talk in radians this time. The cosine of pi is -1, and the cosecant of pi would be undefined, just like the cosecant of 0 was undefined because y is 0. Okay, now that we have the trigonometric functions of any angle definition, it's easy to talk about what are the signs SIGN of each function in each quadrant. I like to talk about sine, cosine, and tangent, and then just remember that the other three are reciprocals of one of those. So if you remember, first of all, r is always positive, right? And so the sine SIGN of a trig function is going to depend on x and y. In quadrant 1, x and y are both positive. So no matter what combination you have of x over r, y over x, that's always going to come out to be positive. In quadrant 2, x is negative, but y is positive. So that's going to make the cosine negative, right? Because the cosine is x over r. However, the sine is going to be positive because that's y over r. The tangent will also be negative because the tangent is y over x. Y is positive, x is negative. Okay. In quadrant 3, x and y are both negative, which is going to make the sine and the cosine both negative, but it will make the tangent positive because the tangent is y over x, so that'll be a negative divided by a negative. And then finally in quadrant 4, x is positive, y is negative. That's going to make cosine positive, sine negative. So I wish I could take credit for this, but somebody else made this up. If you limit it to sine, cosine, and tangent, that gives you this fun little, we call this kind of thing a mnemonic device, right? Something to help you remember it. In quadrant 1, all 3 of those functions are positive. Actually, all 6 of them are, but I'm just talking about sine, cosine, tangent. In quadrant 2, only the sine is positive. In quadrant 3, only the tangent is positive. In quadrant 4, only the cosine is positive. So A, S, T, C, all functions, sine, tangent, cosine. So the mnemonic device that somebody came up with to help remember that is all students take calculus. Okay? And then if you're dealing with cosecant, secant, or cotangent, just remember the cosecant is the reciprocal of the sine, so it S-I-N-E. So it's going to have the same sign, S-I-G-N, right? The secant is the reciprocal of the cosine, so it'll have the same S-I-G-N. And the cotangent is the reciprocal of the tangent. It will have the same S-I-G-N. Okay, so as an example of all students take calculus, they're asking me if the sine of theta is negative, less than 0, and the cosine of theta is negative, name the quadrant in which the angle theta lies. So let's think about that for a second. The sine and the cosine are both negative. All means they're all positive, so it's not 1. Students means in quadrant 2, the sine is positive, so it's not that one. However, in quadrant 3, out of sine, cosine, and tangent, only the tangent is positive. All students take. All right, the tangent is positive, the sine and the cosine are negative. So they must be talking about quadrant 3. Okay, another example where I can use all students take calculus is in a problem like this. If the tangent of theta is -1/3 and the cosine of theta is negative, that is enough information, believe it or not, to find the sine of theta and the secant of theta. Okay. So first, why don't we figure out what quadrant we're in? We know that the tangent is negative, and we know the cosine is negative. So it definitely wouldn't be all. It wouldn't be quadrant 1. Students means that the sine is positive, only the sine. So I think that's what we're talking about. I think we're talking about quadrant 2, right? Okay. All right, so now what we're going to do in order to find the sine and the secant, if only we could figure out what are x, y, and r, all right, then that's all we need. So let's see. Well, okay, we have the tangent is -1/3. We also know that our angle is in quadrant 2. Now, this is very important because how do I know, you know, they gave me -1/3. How do I know whether to put the negative sign on the 3 or the 1? Most of the time, if you're just doing algebra or something, it does not matter. It doesn't matter. But in this case, it really does matter because, let me just scribble something here. So it says we're talking about the point -3, 1, right? So -3, 1 is over in quadrant 2, isn't it? Okay. So my angle theta must look something like this. All right. It is definitely, we are definitely not talking about the point, we're not talking about -1/3. That also comes out to -1/3. But if y was -1 and x was 3, then we'd be talking about the point 3, -1, and that would be over here in quadrant 4. So I know I want to attach the negative sign to the 3 and not to the 1. Okay, so now that we know that y is 1 and x is -3, we can figure out r by using the usual formula. So r is the square root of x squared plus y squared. So I replace x with -3, I replace y with 1, I get that r is the square root of 10. All right, so now we have everything we need. We have x is -3, we have y is 1, and we have r is the square root of 10. So the sine of theta is y over r, which comes out to 1 over the square root of 10. And depending on who you're doing this for, you might need to rationalize the denominator. And the secant of theta, let's see, I know the cosine is x over r, so that must mean the secant is r over x. R over x would be the square root of 10 over -3, also known as negative square root of 10 over 3. So there's the secant, there's the sine. Okay, that brings us to reference angles. Reference angles are a super important thing to understand in order to be able to evaluate trig functions in other quadrants. So what I hope has kind of happened up to this point is that you're getting a really good handle on quadrant 1. And then, you know, quadrants 2, 3, and 4, it looks like just an impossible amount of stuff to memorize if you take that approach, but you don't have to take that approach. So what a reference angle is when, I'm not going to say it exactly like this. All this stuff that's written at the bottom, I think tends to be a little intimidating to people. So I'm going to describe it like this. When you have an angle in any quadrant, that angle will always form an acute angle with the x-axis. It will form an acute angle with the x-axis. So what you see in these pictures is an angle theta. Here it's in quadrant 2, there it's in quadrant 3, here it's in quadrant 4. And then they have made a second angle called theta prime. This little thing here that looks like an apostrophe is read prime. That's a notation that we use in math. You often don't start to see that until you get to calculus. I'm glad that they're showing it to you now. The prime notation is just a way of distinguishing one variable from another copy of the same variable. So it kind of means, you know, this angle is based on this angle, but it's not the same angle. Okay, but it is read theta prime. So in quadrant 2, you see the acute angle there. In quadrant 3, you see it here. And in quadrant 4, you see it over here. Okay. So what we're going to be working on right now is they're going to give me an angle in some quadrant, and I have to figure out what the reference angle is for that angle. Now at the bottom, they've given you these things that are almost like formulas to figure out reference angles, but I never think about this stuff at the bottom. You can really figure it out from a picture. Okay, so I'm really not going to use that. Okay, so let's look at some examples. So here they want me to find the reference angle theta prime for each of the following angles. I wonder if this is another situation where I forgot to write in. No, I did not. Good. Okay, but I will draw a picture for this. So a 210-degree angle, hopefully you can picture that. 210 degrees means go 180 degrees and then go another 30, right? So it looks something like this. All right. Sorry about the squiggly lines. So then if you look at the acute angle that angle forms with the x-axis, that would be this angle right here. Okay? And so the way that you find that reference angle in this case is you take the 210 degrees and you subtract 180 degrees. It's just the difference between these two angles. I mean, I am kind of using what was at the bottom of the previous slide, but I definitely don't memorize that stuff because I really do think you can figure it out from the pictures. Okay. All right, so the reference angle for 210 degrees is 30 degrees. I think it's fair to tell you, why do we care? All right. The reason we care is because when they ask you what is the sine or the cosine of 210 degrees, it turns out it's going to have a lot to do with the sine or the cosine of 30 degrees. That's why it's really important to learn quadrant 1 like the back of your hand. If you learn quadrant 1 like the back of your hand and you understand reference angles, that's really all you need. Okay. So the next example, oh, they already had the picture here. I should have been a little more patient. Okay, I like their picture better anyway, so that suits me just fine. The next example is in radians. All right, so let's talk through that because I think I have a couple more examples on the next slide. So after we've done one in degrees, one in radians, I'll give you one to try first. Okay, 7 pi over 4 looks like that, right? So again, it's a little more difficult to learn how to sort of think in radians. But if you at least know that pi over 4 is right here, okay, then you can count 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, and there's 7 pi over 4. Okay. All right, so the reference angle for that angle would be this angle right here. Reference angles, by the way, are always positive. So this is one of those situations where we don't pay any attention to the direction that the angle was formed. Okay. So what you have to do here is remember that this, I'm going to think of this angle over here as 2 pi. And of course, we already know that this angle is 7 pi over 4. And so kind of like the last example, it's just going to be the difference between those two angles. So the reference angle for this angle will be 2 pi minus 7 pi over 4. You get your common denominator, and that reference angle is pi over 4. Okay. And again, I'm not calling it negative pi over 4 because I'm not paying any attention to the direction. All right, so now I think you're ready to try one of these. The next example is theta equals negative 240 degrees. So if you're watching the video, I'm going to ask you to pause the video, try this one, and then we'll compare notes. All right, so negative 240 degrees. Let's see how that works. Here's a picture of that angle. So you see the reference angle is right here. Okay. Now, when the angle is negative, that does make it a little trickier. And also, those formulas that were at the bottom of that slide that defined the reference angles, those formulas don't work unless the original angle is between 0 and 2 pi. So I think a good way to do this might be to start by finding the coterminal angle that's between 0 and 360. It'll be easier if we call it by that name. Okay. So it's going to be the difference between 180 degrees and that angle, and the difference between quadrant 3 and quadrant 2 is that in quadrant 2 you put the 180 degrees first because that's the bigger angle. Okay. So this reference angle would be, whoops, I missed. This reference angle would be 60 degrees. Okay. All right, so got one more example for you to try. This one is a little tricky. The next example is theta equals 3.6. So I believe I've said to you that when you don't see a degree symbol, it is fair to assume, or you should assume, that that means that the angle is in radians. So you need to figure out which quadrant is this angle in to begin with, and then try to draw a picture of it. And then from the picture, you should be able to find the reference angle. You might not know how to write the answer, though, and that's something we'll talk about. So I'm going to ask you to hit pause, do what you can with that, and then we'll finish it up. Okay, 3.6 radians is in quadrant 3. And the reason I know it's in quadrant 3 is because pi radians, which I'm going to cheat and use this picture, pi radians is right here. Okay. And pi is about 3.14. If I go down here to 3 pi over 2, I don't know that exact decimal, but it would be somewhere in the neighborhood of about 4.6, 4.7 radians if you change it to a decimal. So if you think of this as 3.14 radians, think of this as 4.7 radians or whatever that is. 3.6 would be somewhere in between. Do I have a picture for this? I can't remember. I don't. So let me scribble one real quick. So that means 3.6 radians is somewhere in here. And here's pi radians. Okay. So my angle is in quadrant 3, and that means the way that I find the reference angle is by subtracting pi. So I have two things here. I have the exact value, which would just be 3.6 minus pi, and you could leave it like that. Or if you want the approximate value, it would be about 0.46.